So this is the last part of today's session. And yeah, I will just do something very quickly so that we can go and code or have a break for coffee. So let me start sharing my screen. I changed the name of my presentation to visual break because I want this to be a break. Let me start this. My presentation, the button. That's 5, right? Oh, yeah, play. Yeah, play. It doesn't work because I'm clicking on Zoom. Okay. Yeah, so this is just a visual break, so I will just show pictures. And specifically, I will show things that are, were done with the new backend, which is experimental, which is RPR Makie. And yeah, it's pretty awesome because we can do ray tracing and the pictures just look amazing. And that's why it's called visual break. And I only have 2 of them, I think. So this is the first one. So you can see like the difference now is that you can actually do like different lights, like to the left, and something like this, cold, and then to the right, and warm, right? Yeah, please ask. And no, in this case, this is the environmental light function that comes with RPM. Oh, so like this picture, that's on the background. The one in the background. No, that's another sphere. So here, actually, I'm inside another sphere, which is the universe. All right. So yeah, I mean, the one in the background is actually a photo of the sky. So yeah, you can ask. So that's good. That's the idea of this session. In this case, it's just a single surface. Yes. Yeah, it's just an image. There's nothing stopping you from doing it. You could do that. But you just have to compute like where the clouds go. Yeah. That will come later. Not the clouds, but something similar. So, right? And then you can even do something like the animation, right? Cool. In this case, I mean, you need some GPUs to render, but the cool thing is that it works. And I'm using the release version of Makie, which is pretty slow because observables is not working currently for all cases. So I need to create the figure every time. And yeah, that's bad. Yeah. You need to load things into RPM. So in this case, every frame is taking 3 seconds, which is not much. You only take 3 seconds. Only 3. But like nothing. No, but I'm using full disclosure. I'm using a 800 GPU machine. So, but I mean, in that machine with the new patches, and if you support observables, then it will be less than a second, which will be pretty awesome per frame. And yeah, I mean, this slide here is just to show like how are we using Makie at the Institute for our projects. So this is a project which is called DeepCube, where basically is a bunch of data cubes in Africa, which we want to visualize in real time and actually see how predictions are done once you train your neural networks. So yeah, this is a dashboard that unfortunately is not a gift here, but yeah, this works on the server. So this is done with web via Makie. So that, yeah, we can explore all the data set live. Yeah, that's basically it. We have another project which is called Ceasefire, also uses data cubes. And yeah, I can do basically the same exploration as the previous one. The main idea here is that we do a lot of data cubes. So we are using these packages specifically, like Jax arrays and SAR, so that we can do out of memory computations and yeah, do everything fast. That's basically it. This is completely blank because this is why we want to use Julia here. And yeah, I mean, the objective here at the Institute is to actually do the model of our air system globally. So we actually want to create models that can do predictions in a global scale and at high resolutions. So that's why we choose Julia, because it's supposed to be fast and work, but yeah. But this is the goal. I mean, the goal here at the Institute is to actually do these simulations and in a very efficient way and visualize them. Yeah, so this is basically like the visual rate, yes? So in that case was the wind speed. Yeah, I mean, I just use hopefully a good format that so that you can see yeah, the intensity of the wind speed. Yeah. So this is the thing about visualization, right? I mean, to actually be able to visualize something and get some insight. And yeah, so okay, I have this for, I mean, I have this for several variables like temperature, precipitation. So you can do all these kind of animations already with Makie and have this high quality output. Yes. That's a good question. I mean, here in the previous video, let me go back because I don't know what's happening here. This one is just data. I mean, it's just the wind speed. Yes. I mean, in this case, what I'm doing, I'm just doing, I'm using the spherical transformation. I take long lap and I do an X and Y and Z array of values for each one of them. And long lap, and longitude and latitude, and longitude and latitude. And then I do the projection to the sphere using cosine, sine. That's it. Actually, I will show it now in the next slides. I think I will. So you can have the plot here. What I'm using here is a surface, yes. So in this one, I'm using a mesh. Oh. This one is mesh, and the other one is surface. Because yeah, I mean, if it's just an image, you just use mesh. If it's data, I prefer to use surface. Yeah, yeah. The resolution is lower. And as for the data, I mean, all the data, as I mentioned before, is stored in SAR format. So, and we do the loading lazily so that you don't load all the data at once. So when I render one frame, I just load one time step. That's it.
You can interrupt. So using the X arrays and Z arrays, it is actually possible to store other kinds of meshes. So for example, if you're looking at ocean dynamics, you could have a mesh structure which has no singularity at the North Pole. And so you could store that there. We can plot that. We've got examples of those as well. So Makie is pretty flexible in terms of like the structure of data you have. As long as you have points and like connectivity, you're fine.
So actually, yeah, I mean, I'm showing this because I want to have other points of view on how can we improve this. So if we can do that, we can do it. And what else do I have here? I just have, yeah, this was why Julia, because we want to simulate the whole system, and live coding, and that's basically it. Really, I mean, this is this visual break, basically. And I will try to do some live coding for some things. If they don't work, we can ask Simon or Julie why they don't work. Because it's Makie, right? So yeah, I mean, as I mentioned before, I have some. Yeah, this was like the work how to visualize something variables, but yeah, nevertheless, let's go to the. So what I do, I mean, for the first movie, what I do is basically I just take the image from the Blue Marble website from NASA. I download the image and I just do mesh, sphere, color, image. That's basically it. I mean, you don't need any of this. You just do this, and then you should get this. Okay. So that's basically it. I mean, it's say I want to plot mesh, which is a sphere, right? Here. I want to put some color. What is the color? My image. I think Simon did this one a few years ago. For me, it just works. I mean, I'm a user, so if it just works, it just works. Yeah, a lot of questions out there. Yeah, you. It's just how does it look? It looks like. Can you pass around the microphone? Can I do heat map here, right? Heat map. You mean like Earth image? Ah, like image. Oh, yeah. Okay. Earth. Yeah, that's an issue that I was. This is on purpose. Like that is an issue in Makie that I wanted to be fixed. Like, I mean, when you do image, then you don't get the right. Get it over rotated, right? Yeah. Transpose rotated. Yeah. So usually you will get this issue. So what you do is you have to plot R neither, right? And then you get it right. And yeah. So this is how it looks for you. Okay. And then yeah, this is the powerful. I told it. So what I wanted to say here is that sometimes when you want to do like a simple plot, you don't need to declare figure, resolution, or anything. You just do function, and then you get it. And if you want to pass extra options and you don't need any layout, you just want that figure in a specific way. You just pass the extra arguments like figure and axis, and yeah, if you want something else, right? So you do this, so you should be able to get this kind of plot now. So where I am applying a zoom, I'm putting some different background color and specifying some resolution. And also, I mean, this one is also interactive, right? So. You mean because of the distortion? Yeah. Yeah. Let's see. I mean, let's see. Perfect. Yeah. I mean, I saw this issue. I mean, Trevor was working with it like for a year, right? Like it's not working perfectly, and then another issue and another problem doesn't look right, and then you take care of that. So that's fine. You mean here? Just in the color? Same size. This should work also, no? This. Yeah, but then you don't see this. There's a problem so much. I think this is the problem that you're looking at. So you're looking for this problem, right? Yeah, this is the problem. I mean, it's there, but yeah.
So can I say one thing? The way that these images are stored, right, is by latitude and longitude. So actually the way they're stored, you don't get this issue because, naturally there are the length of a latitude is constant, but there are more cells around the poles than there are at the equator. So when you have really small images, you get like very little data at the equator, but a lot of data at the pole. So.
Yep. You want to say something?
Set exaggerated topography layer on and have that image wrap in a sensible way on it too, and then with the ray tracing, get all kinds of nice.
Yeah, you can do that as well. I mean, why I don't have the example here? But yeah, it's easily done. So, it's not there anymore. It's not there anymore. Okay. So the next one is something that I would like to have in Makie as well, like in the doc.
I have one very basic question. In the talk before lunch, we had this comment that you don't have this like simple plot opening function in Makie, and that's also my experience like in the terminal. So when a window opens here now, when you just run mesh or something, is that a feature of VS Code or?
No, I mean, it's the backend. I mean, I'm using gear Makie with gear Makie because I don't have to do that.
Okay. So I guess I use Makie that doesn't work. Is that?
With Makie, you will get the figure here in the panel. Yeah.
Okay. Yeah. So in the terminal it doesn't. Oh yeah. Okay.
Yeah, people tend to be confused by that. So I don't know if everybody knows about this Makie inline true or false thing. Like, who knows about that? Yeah, so not a lot of people. Okay,
But
so
just by chance,
just by chance. So yeah, the base issue is that if you do you kind of know about the Julia display stack a little bit? Okay, so okay, let's say the way that things usually are displayed in Julia is by just checking on the display stack what is the first thing that says it can display anything. And if you have open VS Code, then there's going to be a VS Code display there. And then it's going to ask it like, can you display SVGs? And then it says maybe no or yes. And if it says yes, then it's going to call the rendering function in SVG on it. And if it says no, then it might check PNG next and so on. So that's the normal display stack. But with GL Makie, because we have our own windows, we're kind of outside of this display system, and that is what this toggle inline true or false means. So if inline is true, then it tries the display stack of Julia, and if it's false, then it's going to use Makie's own thing. And for Cairo, Makie, that for a long time didn't make any difference, or because Cairo had no way of displaying anything. But by now it opens like your image viewer or like a browser window or something if you have it to inline false. But it seems like the default is true, and if you're in a terminal and there's nothing to display there, there's no display on the stack because you just have a bare REPL, then nothing will display. And it seems to happen often for people who try it out first. But there are packages like Sixelterm.jl, I think that's called, and they add a display for the REPL itself, for the terminal itself, if the terminal software supports that, and then Makie realizes that there is something that can display PNGs, and then you will have your plots in your terminal. But that's separate functionality from Makie. You might just add it. I don't know, like if it's a big dependency. Maybe.
I mean, you should add that to the docs, really. Like,
Yeah, I don't know where. It's probably somewhere, but probably not where a lot of people see it,
yeah.
and it's outdated. Okay. No,
Okay.
it's good to know. Yeah, but
Okay.
that's the story behind it.
Before I finish, I mean, I will finish with this one, and then yeah, we can talk about other things as well. Yeah, as I mentioned before, we are using these SAR kind of files to load the data, then so that we can select variables or time spans and just do our plot, right? And yeah, I mean, this can be, I mean, I think you can see how big this data cube is here. Ah, okay, this one is really small because I can do, so I can do it here. Run it again just to see the original size. Yeah. That's fair, right? I mean, it's not that big, but it's not that small either. So the good thing is that you can select the time that you want to plot and just load lazily that data that you want to plot. And in this case, I did some functions just to translate the data into the sphere. And I just did a bad color map by hand. I mean, something that I really like about Makie is the ability to define your own color map if you pass a list of colors. So yeah, you can say first white, then snow, 3, gray, 50, blue, orange. A license? Do you need a license for that? I don't know. So the only thing is that I do like to do these things, like to define my own color maps, even though probably sometimes they don't make sense. But I do like it. And Julius was mentioning the other day about this keyword relative. So I use relative a lot for the color maps. So because I usually don't like to have the full color map, the full height. So I just usually say relative 0.5 and then it looks nice, at least for me. So this is how it looks like. So this is the color map, and then this is how the thing is here. And just to finish, I am always looking for this piece of code. What I was saying, I mean, it's not like it's good. It's just like you can do it, okay? So the other thing that I do like is, I do like, but I'm always looking for it. Is to have this animation always running. Just because it looks nice also. So in this case, you can add a button, right? To your plot, right here, this plot here. And then you can do play, and then this will play the animation. But okay, before I do that, I need to run the actual code that will listen to that button, right? So this piece of code here, I really don't understand what it's doing, So I think it should be documented somewhere and be out there also. So once you run this, then you can go to your animation here. And okay, I will resize this window just to make it nicer. Yeah. You can resize it then, right? The thing that I do like about this Makie thing is that you can be playing, and then you can see the animation running, but you can also interact with it, right? You can rotate it and then still run. So this thing, I think is pretty cool in Makie. And yeah, I will finish with that. Yeah, open to question or questions or code or whatever.
Thank you. And I have two questions. The first one is, how do you define the angle of view? For example, when you zoom in on the Earth and you want to change the angle from looking upside down to take some other angle rather than just perpendicular to the Earth.
That's a so high level question for me. You need to access the camera. I mean, for starters, you need to access the camera, and then within the camera, you have the options here, the camera controls. So you will have, I think I can do it here already. You will have the options to choose the eye position where you are trying to look at and the orientation as well. So I actually don't know all the details about it because I don't use them.
Okay, and another question, how do you add some external points rather than standing on the Earth's surface? For example, some high altitude cloud and other layers of Earth.
So I will just do another sphere on top. Or what do you mean exactly?
Consider some other external point. For example, I don't know.
Okay, let me do that, okay? Let me try to do that now. Okay, you mean... Okay, I need to go back to the Earth. Yeah.
Latitude, longitude, and also elevation.
I mean, if you have everything in longitude, latitude, then I would just do a point in longitude and latitude. I mean, I will go scatter or mesh scatter and with the location of your new point. Yeah. Okay, let me try.
Oh, yeah.
I mean, in this case, I know that everything lives in a unit. Where? Yeah. So the radius is 1 here. Everything is normalized to 1. So I can always add a new point at a given location. So here, X, Y, and Z. So the same thing you can do with long lat, and then you get the elevation. So yeah, you can just add new things. I hate the camera. I really want this merge, but yeah.
This is interesting. So you guys will see, this is a mesh, right? But because it's a mesh, because it's just a bunch of triangles really, you can see that the Earth doesn't look smooth. It looks kind of pointy. Yeah. So that's because the mesh is not extremely fine. It's a pretty coarse mesh. You can make it finer. There are ways to do that. But it's just something you should keep in mind. Yes, this is a mesh. You're just putting an image onto the mesh.
I have a function for that actually. Let me just grab it.
I mean, they're really efficient, but
Sorry?
it's really efficient, the mesh representation, but it does have this thing that you have to keep in mind.
You say something? Joking, okay. I always have a function for something, right? But it's not here unfortunately. Really? How? How here? I mean, how here directly? Okay, I will not do it because I don't know. Okay. Yeah, I get it. So what else?
So you're using this ZR package or yeah, like the data. Is it like it sounds to me like just another way of representing large arrays? Okay, so does it have like any benefits over like Arrow or HDF5 or something? Or what's the reason why? Yeah, what's the reason you're using it?
No, okay, that's the first reason actually. No, but the second one is that for me, it's the one that I know. The other ones, I don't know.
Okay.
And I haven't tried them.
Okay.
At all.
And then you're also using this YAX arrays, which kind of does the same or not?
Yeah, the Jackson arrays for me is just to easily access the whole thing, like time, variable name, to do subsetting of longitude, latitude.
Okay.
Yeah, select regions. I mean, I can also do like region Europe, and I can get Europe, Africa.
Do you happen to know if it's similar to this dimensional data method?
It is.
Just to add to this, so ZAR is just a data format. You could also use NetCDF. ZAR has the advantage that it's optimized for cloud access. So you have small chunks, and then you can grab just a piece of the data because you don't want to load all of the 500 gigabytes.
Yeah.
You only want to open the small stuff you're actually interested in. And YAX array is basically a wrapper around the format. So it goes ZAR, NetCDF, and everything that ArchGDAL opens. And then you can, so you can have this access by name dimension. And it's, I think the more important thing is that it's also trying to use in map slices and mapping of different user-defined functions over the dimensions and doing this in distributed and sorted ways. And we're currently working on integrating YAX arrays and dimensional data. Basically making both packages have a struct for representing arrays with dimension names and labels, and we get rid of the YAX array subtype and make that a subtype of dimensional data.
Okay. Since we are now just talking and discussing. Yeah, go ahead.
Do you know if there's a way to also visualize streamlines in data sets? Like basically lines that follow, for example, the direction of the wind or something like a bit like a simulated airflow.
I mean, we have a function for that, which is called a streamplot. So you can pass, yeah. You can do fields. Here, streamplot.
And you could you combine that with this 3D visualization of the Earth, or would that not work? Okay, that's just 2D.
Yeah, this is. You can combine, yeah, I mean, you can do these stream plots, you can also do them in 3D. I was just looking for the example, but I don't have it here. But it should work.
That's interesting because it turns out that there's a particular way that you can change these streamlines in 3D with a particular specular reflex that emulates them to look a bit like fishing line. And the funny thing is, once you see this, particularly when you turn it animated, as a human, you immediately get a very good impression of how this whole 3D screen field works. That's a trick they use in Amira, but I think it needs a little bit of tweak to the renderer to get this right.
Okay. I would like to see more about this.
I can show you some examples.
Yeah,
I can
please
send
show
you a
me.
paper about it.
Yeah, okay. Yes, yeah. Okay, I wanted to show something that probably I haven't seen here much, like when you use the Makie primitives, like you want to, I mean, I saw this in the data frames. I mean, for me, it's a rule, like, if you use a keyword more than twice, you should define that outside of the calling function. So if I'm using color 3 times in the same plot that I want to do, for instance, if I do color equals red here, and then I do another scatter, which will call it again red, right? Another equals red, and then I do current figure, right? Just to get the current figure. So this repeating thing here of the color, I usually just put it outside, and I define the global color for this, and I just pass color. You don't need to type again color equals red. You do it like this. Wait, it should be random, right? What? Student? Let's see if it works. Work, right? Julius approved. I mean, I prefer to put it like this. If I was using color 2 times, then I would just use color outside and then just go like arguments, right? So the same is for heat map. I mean, if I do heat map, I just define a color map outside and then I use that color map everywhere. So yeah, I think you should take advantage of this because it's very nice. That's it. Good.